Okay, welcome everyone to our Powering Better Energy Prices for Manufacturers webinar. Let's get started. So to introduce the team, as myself, David Evans, I'm the Director of Commercial and Engineering for Flow Power.
And I'm Lachlan Jacobson, Senior Business Development Manager at Flow Power.
So we're going to look at today a bit of an overview of the market, some information on how corporate PPAs or renewable PPAs work. We're going to look at a manufacturing case study and some next steps. So just to cover a little bit of housekeeping, the webinar will run for approximately 30 minutes with 15 minutes for questions at the end. So we'll aim to try and get through all the questions that you may have. So let's jump into it. So a little bit about Flow Power. We're a licensed electricity retailer. That means we sell electricity to customers, but in particular wholesale electricity to large C&I customers or commercial and industrial customers. We're a little different to a traditional retailer in that our model is really focused around reshaping how customers buy from the energy market. And in particular, we focus on connecting customers with the wholesale energy markets and providing transparency and advice around how they can get the best from those markets. And these include things like wholesale purchasing with demand response, but also wholesale contracts and wholesale pricing with things like renewable power purchase agreements, which we're going to cover today. So I'm going to hand it over to Lachlan to provide a little bit of an overview on the market and how we're tracking today.
So just going to talk briefly about, I guess, the energy market evolution in Australia, what are the key drivers, what the outlook is, and what this means for the manufacturing sector. And essentially what most customers are finding when they're going to market over the last 18 months is that they're facing 200 to 300% increases in what they've historically been paying for energy. This is really a function of supply and demand. When Hazelwood closed down with really short notice, there hasn't been enough time for the market to respond and bring new generation in. So prices are currently sitting at near historic highs and are expected to remain elevated in the near term. What we've got on the other side, if you're actually looking ahead over the next few years, is prices are starting to come down because of the influx of new renewable energy generation into the national energy market. In Queensland, there's significant solar energy being rolled out. In New South Wales, we now have 700 megawatts of wind and large-scale solar, with a further 1.2 gigawatts in the pipeline. Similar story across Victoria with 2.1 gigawatts of new renewable capacity currently committed and another half a gigawatt in South Australia as well. So we're seeing this being played out as a key trend around the national market. The next inflection point that's expected is the Liddell coal-fired power plant in New South Wales, which has been announced as a closure before the end of 2022. But over the next 3 years, it's really a story of more renewables coming in and starting to put downward pressure on prices.
Is it fair to say, Lachlan, that the reason or one of the bigger drivers behind renewables is that they are essentially becoming the lowest cost form of new generation entering the market?
Yeah, that's a great point, David. And there's a lot of evidence and research out there that supports that from the likes of Bloomberg, that in terms of the lowest cost form of new generation, wind and solar is clearly ahead at the moment in Australia. And that trend is unlikely to continue. Yeah, as the energy system transitions to a more integrated and cleaner system, it is impacting on the ways that businesses choose to procure energy, and they're looking for new opportunities to reduce their costs.
I think it's also, how do businesses get access to some of these lower cost forms of generation? So obviously, as the traditional forms of gas and coal have increased, as we've seen, you've the 200 to 300%. The question and what we're trying to talk through today is how do businesses actually get access to those cheaper forms of generation, actually benefit directly from that?
And just following that same trend, some of you may have seen Clean Energy Australia's latest report that came out last week. Currently, we're getting 21% of electricity in the national market from renewable sources, which is its highest ever level. The level of investment in large-scale projects actually doubled in 2018 relative to the previous year. and there's currently 14.5 gigawatts of new energy generation that is financially committed or under construction at the end of 2018. And so what does this actually mean for manufacturers? We've got a number of manufacturing businesses that are current Flow Power customers and others that we're talking to at the moment, and it's clear that there's a few basic needs. As I mentioned before, coming off basic retail contracts, many are facing 2 to 3 times increases in their fixed rate contracts, and they're looking at ways to alleviate that cost pressure. Because for a lot of manufacturing businesses, they don't actually have the ability to pass these cost increases through to their customers. They might have offshore competition, so it really just becomes something that's going to erode their margins. In terms of what levers they can pull, some manufacturers are looking at things like CapEx projects to make their plant more energy efficient, or potentially investing money in on-site solar as an option to avoid the need to import electricity from the grid. These are all quite challenging and complex solutions, and they usually require more debt to be taken on, which is not always an ideal solution for a manufacturer. So essentially, it's about trying to get your energy costs down is the key focus, and trying to get some long-term price certainty as well. Manufacturers that are trying to grow their business, invest in staff, and invest in new equipment, if you don't actually understand what your input costs are going to be from energy, that makes these types of long-term investment decisions even more challenging. So trying to look at other ways that you can manage these costs is really important in terms of trying to lower your overall operating expenditure, producing more goods, helping to maintain your staffing levels, growing your business, and keeping your operations onshore.
I know that the conversations we've had with some of our manufacturing customers have indicated that, you know, one of their key drivers is having some price certainty over the longer term. Obviously, being subject to massive swings in price is a significant problem for them when, as you say, that's difficult or potentially impossible for them to pass through some of those cost increases. So having that long-term price certainty that renewables can provide is actually a really interesting way of managing that.
Yeah, it's a really good point, and I guess the traditional basic fixed price contract, gives you a high level of certainty during that contract term about what you're going to be paying for power, but it can lead to a lot of surprises and shocks when you actually come back to recontract in the market. Looking at just like the contract prices in, say, Victoria for 2020, they actually have increased by more than 50% since June last year. So in the current market, you're fully exposed to all that variation when you come off contract. So that can be very challenging for businesses investing in long-term infrastructure. So Flow Power launched our corporate renewable PPAs into the market in late 2017, and we set a very ambitious goal of having 10 offtake agreements for wind and solar in every mainland NEM state. And now we've actually achieved that goal less than 2 years later. We've also committed to close to half our renewable portfolio to Australian businesses. So of the 450 megawatts that we have actually contracted, almost half of it's actually committed to clients, which is a testament both to the growing awareness amongst businesses and an appetite in the market for corporate renewable PPAs as a way to manage your costs. We're not expecting demand to slow down. If anything, we're seeing awareness of this opportunity and interest in it increasing. So what does this actually mean for the renewables sector? If you've navigated the process of establishing a PPA with a renewable plant, you'll know that the process can be long, difficult, and unfortunately closed off to businesses below a certain level, just because of, I guess, the scale that's required to be able to independently negotiate a contract like this. Now, our corporate renewable PPA, or our virtual generation agreement model, opens this market up to smaller businesses, and it provides crucial support to Australia's pipeline of renewable projects. The remaining 241 megawatts that we have available could power more than 200 businesses for the next 10 years.
Excellent, thanks Lachlan. So I'm going to talk a little bit about what it actually means to use renewables. And one of the terms that we've introduced in this webinar is a term called PPA, which actually stands for Power Purchase Agreement. It simply means an agreement between the off-taker or the purchaser of electricity and the generator. So that term PPA you'll hear in the market, just to clarify. So why PPAs or power purchase agreements from renewable generators are beneficial for manufacturers? Well, we've sort of summarised here in this slide that in addition to what Lachlan has already covered, the revenue certainty, the requirement for investment in terms of the generation side, having the certainty of revenue from contracting their generation output provides a lower cost of capital, provides more certainty around the project, and in many cases it actually allows the projects to get built. And it provides obviously some additional capacity in the market, community support. On the flip side, or the offtake side from the manufacturing business, we're seeing reduced energy costs as a result of these offtake agreements or these power purchase agreements, the long-term price certainty. We're seeing a light in industry leadership, so businesses demonstrating to the market that they're prepared to commit to buying from renewable sources, in addition to the sustainability considerations around the green credentials that the business may have. So in terms of purchasing renewable generation, there are a few options out there, and there's different terminologies that float around in the market. So we'll start with one that everyone knows, or should at least is likely to be aware of, which is on-site generation, and that is typically solar installed on the customer's site. We call these also behind-the-meter projects because they essentially sit, or their generation is sitting behind the revenue meter on a customer's site. Again, normally one source of generation being solar. The benefit of these projects is they can generally be a low cost to smaller scale, but generally are actually a high cost of capital in terms of the amount of money required to build them or invest by the customer. The benefit being that they offset network and other charges. So in addition to just the energy costs, the on-site generation will offset things like network charges and environmental and other things like losses. On the flip side, they need space, obviously, to install the solar. It requires some ongoing maintenance and commitment from the customer, and there's normally a long-term commitment there for these projects. So for these to generally be functional, a customer has to be on that site for typically at least sort of 7 to 10 years or generally longer, given that solar projects have somewhere between 20 and 25-year lifespan. On the other flip side, we call these off-site generation, or sometimes front-of-meter is another terminology that's used in the market. And these broadly fit into two categories. One which is called a financial PPA, or a financial offtake agreement. This is where a customer enters into a financial contract directly with the generator. The other style is where the generation is passed through the retailer, or the retailer manages the generation and supplies that to their customers as part of their retail supply. So under a financial or direct contract, these are generally reserved for very large customers. So the ones that you would have seen in the paper are people like Telstra, BlueScope, Mars, are good examples of customers who entered large-scale offtake agreements with generators. They do require some complex legal and compliance engagement. They're often bespoke agreements that have specific capital and specific credit support requirements. For both types of PPAs, the benefits are that there isn't a capital investment generally required by the customer, whereas obviously with the on-site generation is a requirement for a customer to provide some investment. However, in saying that, the on-site generation can also be structured under a power purchase where the generation asset is owned and built and funded by a third party, and then the generation output is sold back to the customer. Under the off-site models, these are generally large-scale projects who benefit from scale of economy, prime positions in terms of solar radiation or wind output, meaning that they get the best of the available resource. So their yield outputs are generally higher than what we see on-site. They are funded by generally low-cost capital, which means their cost to generate is quite low compared to on-site generation. So what we see from these types of projects is generally very low cost of generation available to customers. On the flip side, it's only going to offset the energy component of the customer's bill. It won't have any impact on network and other charges. And we'll look at that in a bit more detail. So in terms of some pros and cons in relation to these different types of agreements, so I'm just going to cover a handful of what we consider to be some of the key ones. So in the offsite example, in terms of generation performance guarantee, so someone actually guaranteeing the performance of the output, that's part of the course with the offsite generation. So a third party is owning and operating and managing that asset, and they're guaranteeing a minimum level of performance. With the offsite generation, we tend to match the volume of generation to the usage, both for the on-site generation and also for the retailer sleeved virtual generation agreements. And this generation is included as part of the retail bill. Now, with the on-site, that can also be included if you're buying your solar project or your on-site solar from your retailer at the same time. With the virtual generation agreements through the retailer, we see greatly simplified contract terms as opposed to the financial PPA contracts. They're also available to smaller customers. So one of the key benefits with the retail model is that the retailer can aggregate up a large number of small customers and effectively buy a large chunk of offtake from a wind or solar or multiple projects and offer that to much smaller customers than they would be otherwise able to obtain from those projects themselves. They also require that in terms of the financial contracts, they require fairly significant legal and financial and stakeholder engagement. As again, previously mentioned, that they're rather complex offtake agreements. They also generally require customers to take both the energy component of the generation, but also the green certificates, or what's referred to as large generation certificates. And in the case of on-site and financial contracts, these are something the customer would have to manage, versus through the retail model, the retailer would actually manage those green certificates for that particular generator. Just one final point there, the large-scale financial PPAs may have some derivative accounting implications because they are a financial contract, in addition to potentially some Australian financial services license implications that may need to be considered. And hence why we see those contracts really being reserved for very, very large off-takers, where they're able to invest the resources to negotiate those contracts themselves. So just flying into that, what our model we call the virtual generation solution. And again, it's an integration of one or more, generally multiple sources of renewable generation in with a market component, or what we refer to as the balance of supply, as a complete holistic retail solution. So that means you effectively cover all your energy needs through a combination of renewables and a market solution, which we're going to cover in the subsequent slides. This, interestingly enough, can also be combined with on-site solar. So if a customer does have a desire or wants to look at on-site solar because there's a benefit from doing so, then this model actually works in really well. So you might, for example, supplement an on-site solar installation with wind, and even maybe top up with some additional solar if you potentially don't have enough roof space, or some of your sites don't have a lease that's commensurate with installing large solar on the roof. So a little more to discuss on how we actually size the generation for a particular customer. So one of the things that's really important about the retail model is it's matching the generation to the actual customer's load versus the financial contracts. One of the points that I perhaps didn't make in the earlier slides was that under the financial contracts, the generation is not related to the retail contract at all. They're treated as completely separate contractual obligations and have their own set of requirements and terms and conditions, versus the virtual generation agreement, or the retail sleeved model, as sometimes referred to, includes a matching of the generation with the customer's load. So the very simple example we've shown up here is where you've got wind, which tends to be a relatively flat profile, often with higher generation in the morning and evening, and then solar, which tends to be obviously generation during daylight hours or solar radiation hours. So we tend to find there's a natural complementary profile between wind and solar, and obviously part of our analysis requires us to select projects that have generally complementary profiles. So when you add it together, you end up with a shaped profile that has a combination of both wind and solar. Now, if that's combined with a customer who has a peak profile during the day, we would generally apply more solar, as we have in the example here, or a customer potentially uses energy over a relatively flat period, we would generally apply more wind. So matching that generation to the actual consumption is actually quite important, because it means that more of the generation is being used to offset the customer's cost. So the customer is relying more and more on the generation to supply their energy needs and less on the market. One of the questions that we generally get asked is, how do I manage my scenario when the wind isn't blowing or the sun isn't shining? And of course, those are inevitable outcomes from time to time. So there's a number of ways in which you can deal with that, and we offer a few different solutions depending on how a particular business wants to address that. So quite simply, a customer can is always going to be supplied with electricity from the market. So I guess a point to make here is that we call these virtual generation agreements because energy is virtually supplied through the NEM, or the National Electricity Market. So if the wind or solar isn't blowing, isn't operating or generating, it doesn't affect the physical delivery of electricity to your site. That is not impacted at all. It simply means that we have less generation to offset it on a particular interval, a particular period of the day, in which case we'll need to buy more energy from the market. And we can do so through buying from the wholesale market. Some of our customers use financial instruments to effectively manage that price, and PowerActive is a way of doing that. Or some of our customers use demand response, or by physically managing load in response to price. There are also options where we can provide more price certainty on that balance of supply, and these can be done through shorter term contracts that most customers are familiar with today, which generally run between 1 and 3 years. And there are also, for some customers, longer term options where we can source long-term match to the PPA term pricing for the balance of supply. So again, just to put customers' minds at ease, there are a number of ways in which we address with a balance of supply. The model is designed to look at the customer's holistic electricity approach, including the portion that's supplied by renewables and the portion that they need to get from the market. So just a couple of closing comments here. In terms of looking at PPAs, there are a few things that need to be considered. First, we've talked about matching generation to the profile. So we would encourage customers to ensure that the types of generation that they're looking to contract with are entirely suited to their usage profile. For example, customers operating during daylight hours or peaking their load during daytime profile are going to be generally more suited to solar than wind, versus a customer operates 24/7. The structures are really important. So for smaller customers, generally greatly simplified contracts through their retailer will potentially be more attractive than more complex arrangements which are negotiated directly with generators. Term, most PPAs or offtake agreements are generally somewhere between 5 and 10 years, and some are longer. So customers need to be able to enter into longer term offtake agreements. And of course, price is important. The only caveat I would say to price is that the customer needs to look at the benefit of a particular generation source. So for example, one source of generation may be more expensive than another. However, if that generation is providing more benefit to you over a greater period of time, the actual outcome may be financially significantly better than a cheaper form of generation. Case in point, you may find an operating wind farm is more expensive than a solar farm that's yet to be built. However, the profile of the wind may be better suited to offset the customer's costs. That's just a point to make on cost there. Cost is not everything. So on that note, I'm going to hand it over to Lachlan to take us through a case study.
Yeah, thanks, David. So brief case study just to finish off is based on a current flow power customer. They're a typical mid-sized manufacturer based in regional Victoria. Looking at a renewable contracting option was not actually part of their decision-making process initially. They were just going to the market as they always had done. And when they received offers that were essentially 200% above what they'd been paying previously, they would realise that their operations were not actually going to be economic at those rates. So they decided to look a bit further afield, try and find something different that they could access, and that's when we started talking to them. We presented a solution based on our hybrid VGA, which was essentially based on analysing their load and then matching wind and solar output to provide the best capture rate, essentially trying to find the highest proportion of time when their demand is going to be coincidental with the solar and wind generation to maximise their use of renewables. This means that the majority of their prices are going to be set at prices well below current market rates for the next 10 years. and essentially has meant that they're able to keep their operations economic and onshore into the future. And based on the savings that have achieved so far, they're actually looking at potentially expanding their operations in Victoria in the near term. So the outcomes for this customer have been 29% saving on energy costs to date compared to the fixed rate offers that they were given towards the end of 2017. They've got that price certainty for the next 10 years, which certainly helps when they're looking at investing in new plants or expanding operations and having more certainty into their input costs. They've reduced their carbon footprint and overall emissions, which, as an aside, wasn't actually a key criteria for this particular business. They don't have a large public profile, but for many businesses, obviously the sustainability aspect is really valuable. And it's given them the flexibility to look at actually expanding their operations because of the reduction in input costs on the back of renewables. And just one other final point, which is something that our engineering services team have been working with this customer on, is looking at potentially using their power more efficiently throughout the course of the day to access even bigger savings. Most of our customers, when they join, particularly when they're looking at renewable energy as a way to manage costs, don't actually need to make any behavioural changes to access significant value. But once you are actually on a wholesale index contract with Flow Power, you do have the immediate opportunity to start using more power when it's cheaper and less power when it's more expensive to deliver further savings over time. So some of the initial analysis that we've done for this customer has been focusing on the Victorian price profile, where we see that high prices almost invariably occur between 4 p.m. and 7 p.m. at night when everyone gets home and turns on their air conditioners, and you've still got a bit of an overhang of industrial load as well. So demand response doesn't have to mean turning off stuff at short notice. It can actually just be set and forget strategies based around historic price patterns. So for this customer, if they were to shift part of their energy intensive processes to earlier in the day and away from 4 till 7 p.m., that's going to deliver an additional 6% of reduction in their actual costs. And that's savings that they'll be able to access immediately. So if they make these changes 1 month, they'll see that 6% reduction in their next energy bill. So this simple change would save them an additional $15,000 a year.
Excellent. Thanks, Lachlan. So we're going to hand it over to the floor now for questions. So we'll do our best. Apologies, we are running a little bit over time, but we'll do our best to cover off any questions here. Okay, so I've got one question here. How is your corporate renewable PPA so different to others on the market? Lachlan, would you want to have a go at answering that one?
Yeah, sure. I think the key difference, and the case study is a good example of that, is I guess the fact that it's integrated into your retail offering, and it's a lot more simplified relative to a financial PPA. So I was at a function just recently where I think Monash University were talking about their own PPA procurement process, and they said that it took them 18 months, and it was a really significant strain on their internal resources because you've got a lot of people doing a really complex project that they've never done before. Contrast that with the example of our Victorian manufacturer. They actually didn't actually start entertaining a PPA until 3 months before their contract was due, and they were able to actually go through the process, make their decision, and finalise contracts in a 3-month period. And then they had access to this 10-year virtual generation agreement that was integrated into their electricity supply. So, I mean, clearly it is, there's always going to be an additional layer of complexity relative to a really basic traditional retail offering. But I guess once you've run the numbers and done the analysis, it does operate very much in the same way as any other electricity supply agreement does. You receive a monthly bill. The way that the price is calculated is a little bit different. But once the contract's in place, it actually removes you from a lot of those market exposures and allows you to get on with business using renewables to achieve a much lower cost for electricity.
Great, thank you. I've got one here that says, what type of manufacturing businesses would be most suited to signing a corporate PPA? So by corporate, I'm assuming they mean financial PPAs, which is directly with the generators. So I maybe try to answer that by saying that in terms of manufacturing businesses suitable for renewable generation, I would argue that all manufacturing businesses are suitable. Now the question would be around matching the types of generation to the customer's usage profile, the manufacturer's specific usage profile. So that would be the short answer. In terms of who's suitable to sign a financial, or what was often called a corporate PPA with a large wind or solar farm, again, it would generally be a larger user that has significant capacity to negotiate an offtake agreement of sufficient size that the generator would entertain. So again, the sort of the examples I provided earlier with people like Mars and Coca-Cola, large food and beverage manufacturers who have significant energy footprints, they are able to negotiate a fairly significant chunk of the generation from a particular project. One of the challenges, of course, is that they've only negotiated generation with one project, and potentially those customers may benefit from negotiating generation from multiple projects, things like wind and solar combined. Just heading back to the questions there. Do you offer both wind and solar PPAs? Are there any differences between the two? Do you want to have a go at that one, Lachlan?
Yeah, sure. As we mentioned in the earlier slide around our list campaign, our goal was to have wind and solar capacity available in all the mainland NEM states, and we've achieved that goal. So yes, we absolutely do. We have solar and wind capacity available in all of the mainland states. And the reason that we've done this is so that we can actually offer a blend of wind and solar that provides the best match for a customer's demand profile. And in broad strokes, what that means is customers that have got fairly flat loads, like they use a pretty stable amount of power 24/7, it probably means that they would use more wind power because that's got more of a stable profile across the day. Customers that have got more of a peaky load profile, where it's more of a daytime load, we might weight their contracting more towards solar versus wind. So yes, we have both. It does actually smooth out the production risks. So you've got a more consistent renewable energy profile if you're actually spreading your contracting across two different fuels and two different projects. And also it allows us to provide a better fit for the customer's actual demand profile. I guess besides that, it's not a huge amount of difference. Obviously, just the nature of the fuels does tend towards a different level of variation and also profile. So solar is more consistent, but obviously only available during daytime hours relative to wind. But yeah, together they're very complementary, and most of our customers that are accessing this particular opportunity are sourcing both solar and wind, which is absolutely what we recommend to people as well.
Excellent, thank you. I got another question here saying, why are so many customers still so against PPAs? Okay, so good question. I guess I'll have a go at answering that one. The view of Flow Power would be that we're seeing a shift in the market. We're actually seeing a lot more customers looking at at PPAs or contracting with renewable generation as a potential way of managing their electricity. I think the challenge has been in the past the uncertainty and potentially the press around renewables and the uncertainty of generation. So what that does actually requires a customer to potentially be better informed around what the risks actually are. So how you manage your generation, your procurement when the generation isn't operating, that's a key question that a lot of customers want to understand, and what does their overall outcomes look like. One of the biggest challenges that we've actually had in the Australian market is customers accessing that generation. So while there's been quite a number of generation projects being built and forecast to be built, there's not a direct avenue apart from people like us that offer smaller customers or medium-sized customers the ability to contract or buy that output. Often it's reserved with very large retailers or very large customers. So that has been one of the problems or one of the reasons that's prevented the market accessing PPAs. But going back to the earlier point raised at the start of the webinar, renewable generation is actually not going anywhere. It's the cheapest form of new generation entering the market. There's more coming on. This actually means a good story for customers. It means it's driving. We can already see it's pushing prices down in the market. And so there's a great opportunity for customers to get on board and benefit from this lower cost of generation and displace some of our aging coal and gas fleets. So there is some good news stories here. There are some challenges with how we manage it, and we still need to work through those. And part of that solution is the customer, which is one of the things that we would work very closely with our customers to get the best out of that market.
Just one other follow-up point as well. I think the complexity is a barrier as well. Customers think that it's going to be something that's really time-consuming, that they need to spend a lot of time working through. But what we've found with more of our mid-sized customers that have got a less bureaucratic decision-making process, they can actually be quite responsive to this opportunity and take advantage quite rapidly. And that's actually where your best financial outcomes are going to come from by moving fast, because the markets are very expensive right now, and they are going to come down the next couple of years. But actually contracting renewable energy in the current market is a lot more valuable than waiting 2-3 years. So businesses that can be agile and move quickly under a model like ours, where it's a lot more streamlined, they're going to get better financial outcomes than those that wait.
Excellent. No, good. Thanks, Lachlan. So one of the questions here I've got: how are LGCs taken into consideration with the VGA? So LGCs, for anyone that doesn't know, stand for Large Generation Certificates. These are the green certificates that are produced by a certified renewable generation plant. So under the virtual generation model or the flow power model, the customer has the option to include those certificates if they want to, in one of two ways. They can use them to offset the current LGC charge that every customer sees on their retail bill currently, and that's to do with the renewable energy target, which is a federal based target. So those certificates can be purchased from the generator to offset that liability. They can be purchased in addition to that, or a greater number of certificates can be procured by the customer to claim a offset or a reduction in carbon through different schemes such as green power. Or the third option is the customer may choose not to contract the LGCs, and potentially that's one of the most significant advantages with the virtual generation model, in that you can elect to not buy the LGCs if you don't want to. And for many customers, this is an attractive outcome, as they don't necessarily want to manage that LGC component. Sorry, another question here. Do you think the current grid can handle this much renewables? Did you want to have a go at that one, or?
Yeah, sure. So this is very topical for anyone that's building renewable energy at the moment, is actually getting the grid connection. And another acronym that some of you might be familiar with is marginal loss factors, or MLFs. So essentially, renewables do actually get impacted by how far away they are from the customers that are actually going to be using the energy that they generate. So it is going to be a natural limit on how many renewables can be put into a particular market, how well equipped the grid is to handle that additional power in terms of the bandwidth it has. So the projects that are connected and generating now are only able to do so because the market operator has essentially signed off on them being able to connect. But with some of the newer projects that are being developed, they're actually needing to invest in other infrastructure that can help support the grid stability. So this is, I guess, a broader trend that the state government's working on as well, is ensuring that the grids are equipped to handle more renewables. There's battery storage incentives in South Australia and New South Wales at the moment too. So all of the challenges associated with more variable renewables in the grid have got technical solutions. It's just a question of how much it costs, what's the most efficient way to address it, and who's going to pay for it. So look, it's going to be an evolution over time. The grid's going to continue to be augmented. New infrastructure to help firm renewables is going to continue to be installed in parallel with renewables being rolled out.
It's probably the one point to raise on that is that it probably goes against the kind of traditional thinking that cost for newer projects in the future will get cheaper and cheaper. So one of the barriers to that is the actual cost to connection is increasing, because there is a requirement to invest in transmission infrastructure. Obviously, grid support and grid stability are key issues that have to be addressed by any new projects. So in essence, a lot of the projects that already got grid connection already are connected or to be connected. have effectively been able to enter at a potentially a lower cost than newer projects. So I guess that tends to flow into offsets of the cost decrease in technology, things like solar and wind costs generate project costs decreasing may in fact be offset by increasing grid connection potentially. So it's one thing to keep in mind in terms of if you're waiting out there to see if things get cheaper, they may actually not. So one more question here. How long does the process take when a customer approaches you with a request till they sign a VGA or PPA? That's an interesting question. It can be relatively quick in the case of a VGA, or potentially for larger, more significant deals, they may take some time. But essentially, the contracts are designed to be relatively simple and relatively easy for a customer to sign off on. They look and feel a little bit similar to the traditional retail contracts that customers are used to signing with their current suppliers now, which means that the legal and stakeholder investment is relatively small for virtual generation agreements. If we talk about the corporate financial contracts that we mentioned earlier, generally those sort of timeframes are significant. They can be sort of 6 to 12 months or even longer to negotiate, as they're much more complex. I guess the advantage of the retailer or the virtual generation model is that the retailer has already negotiated the contract. The retailer has negotiated potentially the best possible terms that they're able to obtain through the size, and they've been able to pass those benefits directly through to customers.
And I think we've got one final question here around whether there's minimum capacity for a customer to sign a PPA. And I guess with a PPA, then there would be. If you're going directly to a project, you'd need to be dealing in megawatt size quantums. Under our model, as long as you meet the wholesale customer test, we can provide you with a virtual generation solution. So in financial terms, that probably means a customer that's spending, say, $4,000 or $5,000 a month on electricity, they're likely to meet that test, and we could actually provide them with a contracted renewable energy solution. So that's anything from quite small companies up to those that are spending millions of dollars a month on electricity.
Excellent. I think that's reached our time limit, everyone. So apologies if we didn't get to any questions up there. If there are additional questions, please send them through, and we'll do our best to respond to those questions after this webinar. So just take the time to thank everybody for tuning in and listening to our webinar. Any questions, please contact us. The phone number's on the last slide there.
Thank you.
Thanks.